Hi, this set of notes is just meant to be a quick review over scientific notation. I know that you've done this before, so we're just going to review it really quickly. So if you remember, scientific notation is just a shorthand way of writing really large or really small numbers without writing all of the zeros. Comes in handy. In science, we deal with really small and really big numbers sometimes. So for example, the distance from the sun to the earth is 93 million miles, lots of zeros. So step one, we're going to move the decimal to the left and leave only one number in front of the decimal. So 93 million miles, we move that decimal all the way over so it's in between the 9 and the 3. And then we're going to write that number without the zeros, 9.3, step 2. And then we're going to count how many places we moved the decimal and make that our power of 10. So we moved it 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7. 7. There it is. 9.3 times 10 to the 7th miles. Okay? So the power of 10 is 7 because the decimal moved 7 places. Pretty simple. So 93 million, this is in standard, what we call standard form. 9.3 times 10 to the 7th is what we call scientific notation. So here's a practice problem, right? In scientific notation, decide the power of 10. So 98,500,000 becomes 9.85 times 10 to the If you said 7, you were correct. 64,100,000,000 becomes 6.41 times 10 to the, and if you said 10 to the 10th, you're correct. 279 million becomes 2.79 times 10 to the, if you said eighth, you are a genius of scientific notation. 4,200,000 becomes 4.2 times 10 to the, that's right, 6th. You're so smart. Here are some more problems. On these, decide where the decimal will be moved. Dun, dun, dun. So 734 million becomes 7.34 times 10 to the 8th. For number 2, it becomes 8.7 times 10 to the 11th. And again, we're just following our rules. And number 3 becomes 9 times 10 to the 10th. So now we're going to write these in scientific notation. So number 1, if we move that decimal over, it's going to become 5 times 10 to the 4th. That's correct. 2 is going to become 7.2 times 10 to the 6th. And 3 will become 8.02 times 10 to the 11th. So now if we go from scientific notation back to standard form, we're going to move the decimal to the right as many spaces as the power of 10. So 3.4 times 10 to the 5th in scientific notation becomes 1, 2, 3, 4, 5. We're going to move the decimal to here. And we get 340,000. So now we're going to practice that again. 6.27 times 10 to the 6th becomes 6,270,000. 1, 2, 3, 4, 5, 6. There we go. 9.01 times 10 to the 4th becomes 90,100. Move it 4 places. Small numbers. So step one, we move the decimal to the right until there's only one digit to the left of the decimal. Okay, so we want the decimal to be here. 4, 5, 6. Okay. The number of places we move is the negative exponent on the power of 10. So since we're going the other way, it becomes a negative exponent. So it's 2.91 times 10 to the negative sixth in scientific notation. So in scientific notation, this one would be 1, 2, 3, 4, 5, 6, 7. Should be 2.54 times 10 to the negative seventh. Got that one right. Number 2, 1, 2, 3, 4. So this one should be 6.8 times 10 to the negative fourth. And the last one, that's a lot of zeros. So the correct answer should be, good job, 5.4 times 10 to the negative 11th. And that is the end of our review of scientific notation.